So slab opening rebars, we need to set it in the slab opening only. So just now I explained you. So you can set the slab opening rebars and then you can make the opening at the required location using the point command. So drop panel we can make for any dimension, and then rebar if you want to modify, you can modify the rebars here. So it is a predefined rebars they are showing. Always you can modify that. So after making the drop panel, just you need to place the drop panel at required location. So here it is automatically truncating because we have made this as a sunken slab. Let's see here. So generally the drop panel should be done only after making the slab, so that depending on the levels, the drop panel will be cut automatically. So bring again here the sunken slab. So when you calculate, you will get the drop panels quantities, rebars. So after that, a ramp and a spiral slab. Spiral slabs, so we can make the spiral slab. And then at any location, if you want to place it, I can place the spiral slab. You see in 3D, the slab will be something like this. So maybe we can modify the angles. Even the thickness, if you want to set some 200 thickness, and then rotation angle in 360 degrees. Spiral slabs can be done like this by adjusting the angles. So rebar again, we can fill it in the attribute editor. So vertical bottom, horizontal, and then horizontal bottom. So horizontal bottom is shorter side. So T20 at 200 center to center. Vertical bottom is uh, along the spiral slab. So vertical T16 at 150 center to center. Again horizontal top with the same rebars interface. So horizontal direction 20 dia. Then we need to fill the rebars like this. When you calculate, the rebars will be done. You see in 3D, the entire rebar will be shown in 3D like this. So any extra bars, if you want to include, that can be included in the other rebars. In other rebars, we can include any rebars, but only thing is all the information we need to give manually in the other rebars. So when you give the additional rebars, it will be saved with the entity. So this is spiral rebars. Again, a ramp. So ramp again is almost is like a spiral slab. So maybe you can make the, like in TAS, here also you can make the ramp of any shape. So now maybe I will make a simple ramp. So there is a rectangle. So we need to set ramp command. So I'm saying this is the ramp, and then we need to set the levels from this point to this point. Either we can set the level or we can set the ratio also. The ratio if we're setting, so 1 is to 8 or 1 is to 6, whatever levels, then the ramp will be generated. So for the ramp also same way. Just we need to set the rebars here. Just in the horizontal and then vertical is along the ramp. So when you calculate, you will get the ramp rebars also. This floor slab strip is nothing but mainly for the flat slabs they will be making. So that is also straight for a straight that you can make any floor slab strip and you can place it at the required location. So can you try this? So what and all you explored now. So how to make the slab opening? So just to go to the slab opening, you can make any slab opening. You can modify the dimension here and then fill the rebar information. Before making it, you should fill the rebars because it's a entity property. So I can make some 80 12, some 80 12 here, 16 T 12. Both top and bottom, I have set it here. So we can bring any opening, and we can place it. When you calculate, you will get the trimming bars for the openings. So when you place the opening, the main bars will be automatically adjusted. Similarly for the drop panel. Drop panel also, straight away you can make some drop panel. So it's a predefined rebar information. If you want to modify, you can modify. So for example, T10 at 100, T10 at 150, like that. So just simply when you bring the when you bring it near, then automatically it will be cut. The dimension we have set it as 1000. That is why it's showing small. And then spiral slab. Similarly, you can make the spiral slab rebars. You can make the spiral slab, modify the angle here, whatever angle you want to set, and then fill the rebars here. So using find command, you can place the spiral. So all these are all predefined. Similarly, ramp. Ramp also you can make any ramp. When you draw it, you will get the when you fill the rebars, you will get the rebar quantities. So any doubt till now? Because for certain shapes and all already it is a well-defined standard rebar shapes only people will be using. The same shape they're automatically they're giving. So maybe here the masonry wall. For the masonry wall also sometimes the rebars will be given. So maybe I can show that here. So for the masonry wall, you can make a masonry wall of any thickness. So here they mentioned actually what is the rebars you want. So masonry continuous bar and horizontal short bar. So maybe I can set it here. How many number of rebars you want? For example, two numbers of T12 at 500 spacing for the masonry. Horizontal short bar again. So if short bar if you want, you can set the short bar also. T8 at 200. So when you are making the wall, function key to align. So these rebars will be placed, two numbers of rebars for every 500 height. And then, so opening, if you are making any opening, maybe tie bars. Tie bars, if you want to make any tie bars, then tie bars also can be done. You can go here, you can make one tie bar, or we can automatically generate the tie bars. Auto generate the tie bars wherever the wall meets. This asking, select the column entity, right click to confirm. So automatically it is generated tie bars. So connecting with the column and the wall. So using the auto generate command, you can automatically generate the tie bars connecting with the column. So this embedded beam yesterday I told. So it's almost like a beam only. If for any continuous lintel, you can use even beam or embedded beam. You can use. Okay. These are all them manually how to calculate the rebars, and also we need to make the for staircases also. For staircases also you have to make manually the rebars. For the staircases here, we don't have any separate staircase elements here. Instead, they are saying single element. There is a single element concept is there. So that is a predefined staircases. So whatever element you want to use separately, like for example here when I am going for the staircases, I can go here in the single element. So I can add one element. So after adding it, there are identification and a parametric input. Identification is if you're having the staircase rebars, staircase drawing, I can import the staircase drawing. I can read from there the shape of the rebars from the sectional rebar drawings, staircase rebar drawings. This I will explain later. This is a predefined staircases, parametric input, we will call. The predefined different types of staircases they're having. You can see here. The staircase starts from a beam and then ending on a beam. Again here with a landing and ending on a beam. So like this, different types of stairs are available. As per your requirement, you can select any stair. So you need to modify the green color values. So this is by default they are showing some values. You can modify the values. So number of here quantity also you can multiply. For example, the same flight is there, the two numbers or three numbers. Maybe you can multiply with the two or three here. If I say, then automatically the numbers will be multiplied. So how to use this feature? So this is a staircase with a mid landing. If you want to use it, so whatever staircase I want to assign here. So first you need to select the stair, then add one element. In that element, whatever type you want to attach, you can attach. How? So now it is not, now you cannot edit it actually now. So in order to edit it, when you just double click here, this generate rebar will be enabled. Generate rebar. Currently it is disabled. When you double click, then generate rebar will be enabled. Now it will allow you to edit as per your requirement. So maybe instead of T16, if I'm making T20 diagram, again this is also same T20 diagram, 20 diagram, all 20 diagram. You can make it, so wherever green color are there, all the greens you can modify as per your requirement. Then when I click generate rebar, the rebars will be generated. This they are calling it as a single element rebar. So when you calculate the calculation, including the calculation rules settings, whatever you said, that is also applied to the rebars. If you want to see in the report, then you should go to the report. So here the single element. So I can disable this one. I can enable the single element. The single element stairs we have done. And I click OK. So single element rebar is shown. The rebar summary again for the single element. So you will be getting output both from the model as well as from the single element when you're using single element. So single element where and all you can use mainly for the staircases, and then if there is a chedja slab, so in that case also you can use. Okay. So before that you have to try how to use the single element. So for example, if you are in the modeling, I will repeat again. You also can try. So for example, you have completed all the column, beam, footing, slabs like that. And then certain elements like even pile, even for the pile also, the rebars cannot be set in the attribute editor. You have to do it in the single element only currently. If you see here, actually pile, though they are showing pile here, but a rebars cannot be filled here. So even for the piles, you need to fill the rebar in single element only, staircase and pile. So how to use the single element? I will tell you again. When you go to the single element, so mainly for the staircase, select the staircase and then click add element. So whatever name you want to set, you can set maybe ground floor stair or first floor stair like that. Then you need to see the list of single element elements. So how to get that element? You need to select here parametric input. So identification is reading from 2D drawing, staircase drawing. Parametric input is predefined elements. When I click parametric input, so I will get a lot of elements. But in the stair, it is better to assign only the stair. In the foundation, maybe you can use pile. Here also again pile cap, everything is there. Maybe if you want to use, you can use in single with the help of single element itself, pile cap. Though the pile cap is there in the modeling. So here we need to add one element, add element, add stair element. Then you need to check here. So what is the type of your staircase in your project? Is it like this or like this or like this? Again, here also you can check like this, like this. So if any of the staircase is suitable for you, maybe you can select. But in order to fill the rebars, it will not be enabled unless this generate rebar is enabled. So how to enable this generate rebar? So whatever staircase you want, you just double click that. I double click. When I double click, the generate rebar will be enabled. Now it will allow you to edit. I can zoom here. I can modify any values, any beam dimension or whatever values I want to modify. I can select. I can modify. Then how to generate the rebar? When you click generate rebar button, whatever we have modified based on that, including the number of threads, number of rices, everything you can modify here. So when I generate rebar, so for the given value, the rebars will be generated. If I want to use any calculation settings, then I can calculate also. That's all. So are you able to make single element? Are you able to use the single element feature? So when you come to the parametric input, you'll be having the list of elements. So whatever element you want, just double click that. This generate rebar will be enabled. Only then it will allow you to edit the information. After editing the information, just click generate rebar button and then calculate. So these are all predefined based on your given values, the rebar quantity will be generated. Similarly for the pile also, you can go to the foundation. I can add element. I can rename it as pile quantity, pile rebars. The number of piles if you want to set, some 45 number of piles. So where the pile is there. So in the parametric input, when I go to the foundation, okay, not in the foundation, yeah, here, in situ pile. So whatever type of piles you want, you can select here again. So in order to edit here, you need to double click. When you double click, it will allow you to edit. So now whatever values are shown all in green, you can edit as per your requirement. So after editing that, when you click generate rebar, the rebars will be generated. So you can calculate, you will get the file rebars. This 45 will be multiplied with the quantity. So this is how we have to use the single element. Similarly for the slab. For the slabs also, so mainly for the canopy, so you can use the single element. You can go here, add element. You can rename it as a sunshade, sunshade, and then just double click. It will allow you to input the rebars. So input the rebars as per your requirement. Then click generate rebar. When you calculate, those single elements can be generated for the sunshades. So here also you have some pit again. Some pit you have. So this is balconies. Again, pad foundation. So if you want to make use of it, you can use ring beam, lintel beam. Lintel beam can be done in the modeling itself. Wall column, tie bar, the different types of tie bars. Stiffener, again column with corbel, double side corbel and a single side corbel. So all are predefined rebar information. It is available in the single element. You can just add one element and then select the parametric inputs and then modify when you double click it, it will allow you to modify the values. After modification, just click generate rebar, calculate, you will get the rebar quantities. So again, BQ is already, you might have seen in the last software. Just we need to add either if you're having the Excel format, you can add the Excel to link your quantities. Or here maybe I can add new bill, new element. So you can rename it whatever you want as per your bill, either it's a footing or column or a beam. Then items, so whatever item you want to add, and then you are going to link only here the calculated quantity. The calculated quantity is V quantity by category, either from single element or modeling. So maybe star quantity, star rebus. So when we double click, the value will be filled there. So just you can open the view quantity by category. It will show all your whatever rebus you have done for putting column, beam, slab, all the rebus it will show. If you want to make any BOQ here, you can make the BOQ here, rebar BOQ. Actually, this TBQ project this command will be there in a TAS, in TRB, as well as in TME. Okay, this one, so you can connect with that fourth module. That module is mainly for BOQ and tendering purpose. You can connect in TAS and TRB and TME for the TBQ software. So this is BQ. BQ is a BOQ, filling the BOQ. You can import your Excel BOQ or you can make one BOQ here. After filling it, you can save it. Whenever you modify your rebar project, you can, when you recalculate, automatically this will be updated. If you want to export into Excel, from here also you can export into Excel. So this is different output again they are giving here. So you can export into Excel from here also. So any doubt till now for anybody? So this is the manual method of filling the rebar information in the TRB software. So once you understood the manual method of filling the rebars, then you can read from the 2D drawing. So wherever maximum possible, you can read from the 2D drawing itself. If anywhere, if you want to make it manually, so now you understood how to make manually also the rebars. Okay, I will go to reading from the 2D drawing. Anybody is having any doubt till now?
No, sir, you can continue.
Okay. Okay, I will show you how to read from the 2D drawing. So again, here also, first you need to do the project settings. So in the project settings, floor settings, so you have to fill the information, insert floors. And then height of each floor you can modify. Any typical floors, you can set it here. Then you can come to identify. So here we have whatever floors you have done. You can select the foundation floor. So in the identify part, so you have to import the 2D drawing. For the 2D drawing, you can select here in the drawing manager. So when you click the drawing manager, you will get this dialog. Here you can add the drawing. Already I have shared one drawing to you, TRB training drawing. So I'm going to work with that. So this is the drawing. So here actually the same drawing they have footing layout, column layout, again pin the beam layout, first floor beam details, terrace floor. Here the first floor bottom reinforcement, slab reinforcement. So actually, if for our software, if you have the rebar information like this, then it is easier. For the footing, if you have the schedule like this, and then for the beams, as I already told you, if you have something like this, schedule for the beams, and then for the columns, or maybe if column rebars, if you don't have like this, maybe you can in AutoCAD also you can simply copy and paste in this format. If you have the drawing in this format, then easily you can read the column rebars. Okay. So first what we need to do always when you import the drawing, you have to see actually they have mentioned something like this. If you see here, so reinforcement in the slab reinforcement, if you see they might have mentioned 1, 2, 3, 4 like that. Then they'll be giving a schedule like this. One means a die at 100 centimeter center. Two means a die at 125 centimeter center. Like that they might have given for the slab. If it is like this, software will not automatically pick from the schedule and it will not identify. Actually, uh, for our software, we need like this. Above the rebars, they should have mentioned the label and then range they should have mentioned. For our software, we need a unique layer of the rebar, unique layer of the label, and a unique layer of the range line. If only three information, if it is unique, then automatically the entire slab rebar will be done. Otherwise, also the slab rebar is very simple. Now you know how to make manually the slab rebars. So I can select a main rebar. When I select single or continuous, automatically the entire slab will be done. So manually making the rebars also is not difficult. So this is a staircase location. So they are not done the stair, and this is sunken area. It's like that. So for this again, we should have the 3D model. If you have the 3D model, only then we can make the rebars easily. So in this TRB software also, we can make the 3D model. So I'm going to, after importing see what happened now, actually they have mentioned as a 1, 2, 3 like that. So automatically I identified and modified that 1, 2, 3. That is why this grid and all changed into T8 at 125 like that. Okay. So first we need to check the scale. How to check the scale? In the tools, we have the distance command. So we need to check the distance from here to here. So 3730. It should be in the mm. Okay, it is to the scale only. So need not to scale. Otherwise, we need to scale the drawing before identification. So here we have the scale CAD command. So you know how to scale it. You need to select the scale CAD. So at the bottom you can follow the help scale area to scale any particular area you want to scale, or simply right click to scale entire drawing. If I right click, I can entire drawing can be scaled. Then I need to select any two locations from here to here. It will ask you to enter the value. If I'm selecting the if I'm entering this 3730, then the entire drawing will be scaled. But anyway, this drawing is to the scale only. So after that, we need to split the drawing because this drawing has got all the layout. To split the drawing, here we have the command, split drawing command. Similar like TAS actually. And TAS also the same commands are there. So I'm going to split the drawing. So this is, I'll rename it as footing layout. Footing layout. And then this is footing rebar. Footing rebar table. And this is plinth beam rebar. Plinth beam rebar table. And then this is first floor. First floor rebar table. Again, this is terrace rebar. And this is column rebars. Column rebar table. Okay. Then maybe the column layout I can identify from the footing layout itself. So I can identify. This is plinth beam. Plinth beam layout. This is first floor layout. First floor layout. And then this is first floor bottom rebars. First floor bottom rebars. This is first floor top rebars. First floor top rebars. Okay. So now we have split it. So whatever we have split the layouts, you can see it here. So always whenever there is a schedule, first we should read the schedule only. So we are in the foundation floor. So I'm going to the foundation, pad foundation. We have the footing rebars. So I'm double clicking footing rebars. This is footing rebars. So I'm going to read. So here we have the identify schedule command. I can select identify schedule. I'm selecting the window. We need to set the heading correctly. So they are given only bottom only bottom layer alone they are given. They have not given the top layer rebars. So this is the footing name. This is the length, width, then height, and then this is rebar along, bottom bar along width, and this is bottom bar along length. That's all. So no other rebars they have mentioned. If sidebar if they have mentioned, maybe sidebar also we can read. So these three we don't need. These rows we don't need. select it, right click, delete the row. This column we don't need. Okay, generate in element. Actually, this center to center also now they're checking, find and replace. So what I can do, center to center also I don't want. So wherever C/C is there, I'm replacing with the empty, replace all. So now if I say generate in element, my elements will be generated. You can see here. So footings are automatically generated from the schedule properties. So now so now elements are ready. If I want to manually place it into the layout, we can place it. But automatically, if you want to place it, I will tell you. So I'm going to the footing layout. This is the footing layout. Even the axis also, if you want to identify, we can identify the axis. I can go to the axis. I can identify the grid, pick the axis sideline. So this is my axis. Pick label. Actually, this I made I replaced with this one. Okay. Label. Maybe pick label. I can select this dimension also. So when I say auto identify, it is done. The grid is done. Maybe this is 1, 2, 3, 4, 5. What I can do, I can modify the number. This grid 2, 3. Okay. I modify the grid number. The grid is identified. So I can go to the pad foundation. So already we made the pad foundation from the schedule. So this we need, it should come automatically here. For that, again here we have identify pad foundation command. Actually, in this drawing, okay, pick sideline. So based on the layer, if I'm selecting, so this is the sideline of the footing. And when I select pick label, so this is the footing label. Actually, column label also they made in the same layer. At least the color difference they made. So better I will select based on the color. Pick label. So select by color. I will select the label. Actually, we can cross check like in TAS whether all the footings have come or not like that. Here, we can enable the pick record layer and we can check whether all the labels have come or not like that. Our AutoCAD drawing is still here. So now footing identified. So here also we have the identification option like in TAS. So during identification, if any information is missing, software will automatically take from this identification option location. Okay, if any unwanted information if it is there, if you want to send it back to the AutoCAD drawing itself. So like in TAS, here also we have restore care entity. So while using restore care entity, I told you always select like this drag window while restoring. But while selecting, you need to use this window. While selecting the sideline of the either column or beam, you need to use this cursor. Okay. So now when we say auto identify, footings will be placed with the rebars. So if any direction of the footing is not correct, even then the rebars will not be placed. So maybe say here at two locations the rebars not placed. Okay, here also it is not placed. So what we can do, what is the name? Just we can enable and check. This is CF3. So maybe CF3, CF3. This CF3. In case maybe if you want to, you can delete it and you can place the CF3. So function F4 for the grip point location. Function F4. So this is with the rebar. And then here also it's not there. CF5. CF5. Function F4. This is F4. F8. Okay. So now it is placed. So when you calculate, all the footings are with the rebars. So they are given only the bottom layer alone. So if you want to make top layer also can be done. You know already how to make manually. So can you do like this?
Sir, one doubt.
Yeah.
Uh, Sir, is there any option for importing that elements from TAS?
Yeah. So here you don't need to make the 3D model at all. If model is already there in the task, straight away you can
Yes.
import that model here. Only
Okay.
the rebar table alone you need to read in that case.
Okay. 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 Okay,
Yeah.
sir. Okay.
So for that, what you can do, you can go to the BIM model. Straight away
Hmm.
you can import the model here. When you have the
Yeah.
task model, here we have task file.
You can directly import that.
You can
Yeah.
directly import that task file, task model. Just the rebar information alone, if you have in the form of schedule, you can read it in the form of schedule. The only thing
Okay.
is,
Hmm.
whatever label they mentioned in the schedule and your
Hmm.
task model should be
Hmm.
same. For example,
Hmm.
footing label name is F1 in the task. Here also in the schedule, F1 should be there.
Okay.
So
Okay.
that
Okay, sir.
the rebars will be input into the model.
Hmm.
You don't need
Okay,
to
sir.
make the model again.
Okay. That is
Yeah,
easy for us. Yeah.
yeah. So can you do it? How to make, how to read from the 2D drawing? Already I have shared that file to you. So you can use that file. Training file already. Drawing file I shared. So what you have to do, just you need to go to the point settings first. In the floor settings, you can set the number of floors. After setting the floors, you can come to the identify and then you can select the foundation floor here. After selecting foundation floor, When you are in the identify menu, then there is a drawing manager. When you click drawing manager, this window will come, drawing manager. So here you can add the drawing. You can go and you can import that particular drawing. When you open, the drawing will be imported. Always when you're working with the drawings, you need to check whether the drawing is to the scale or not. To switch off this one, I think already you know how to switch off the entities. Here you can switch off the entities. So how to switch off the drawing? Here we can switch off the drawings. This is drawing. Whatever drawing we imported, you can see the drawing here. Entities, whatever entities we have done, whatever 3D models we have done, we can enable here. To select the entities, here there is a batch command, batch selection command. When I select, here I can select whatever footings I want to select it. I can select it like this for selecting the footings. So after importing the drawing, you have to first check the scale using distance command. The distance command is present in the tool menu. Distance. You can measure any one distance so that you will come to know whether the drawing is to the scale. It should be in the mm. Then after, if drawing is to the scale, then what you can do, you need to split the drawing. Always it is advisable to split the drawing because sometimes they would have given only one layout alone, but a lot of sections will be there. So software may identify from the section also. So it is better to split the layout separately. To split the layout, this is the command, split drawing command. So always follow the instructions. Select CAD entities, right click to confirm. Just drag it like this, whatever layout you want to make. After dragging it, right click, you will get this window. Here you can type whatever name. If it is a footing layout, type footing layout. Here this is column layout. Then schedule also I got split, and this schedule also I got split. Like that, whatever I need, I split everything. So whatever I split, it is available here at the bottom. This is the footing layout, and this is the footing rebar table, and this is 10th beam rebar table. So like this, whatever I split, it is available here. Then what you have to do, you should go to the pad foundation, and then you should select the footing rebar table. Your footing rebar table will be like this. Then select identify schedule command, drag window. Actually, if performance of the system is poor, then it will be delayed actually. So for example, here sometimes I'm getting immediately this yellow line. Sometimes it will take time to get this yellow line. So once if it is done, then right click. So it will capture all the information from the schedule. You need to set the headings correctly. This is the footing name, and this is the length, width, height. This is the rebar along. Okay, this is the name you need to set, and this is length, width, height. You need to ensure whether it's correct or not. By default, software is done, and then again here you need to set the heading. Bottom bar along with bottom bar along length. Maybe this we can delete it. Right click, delete the column. This we cannot delete because this is generating the element. So currently it is generating at the 0 level. 0 level is nothing but foundation level. So sometimes, for example, if you are generating column, then column can be generated if it is the same information, we can generate to all the flows. So I can delete this row, delete row. I can delete this column. So after this, when I generate element, if there is any unwanted information, if it is there, the software cannot read that, it will pop up a dialog. When I click generate an element, the invalid information, because so anyway, I don't know why this center to center also they are not taking now. Earlier they were taking, now they are not taking it. Okay, what you can do, you find and replace command. You can select find and replace the center to center. You can replace with the empty. So when I replace all with empty, that will be removed. So now when I click generate element, my all the footings will be generated like this. If footings are generated, then we need the layout. I can go to the footing layout. So manually, if you want to place, I can place using point command. I can bring and I can place manually wherever footings are required. Where is a where is otherwise, I can go here, identify command, pick sideline command. So maybe axis also, if you want to identify, axis also can be identified. To identify the axis, you should be in the axis component and then pick axis command, pick based on the layer, any one axis line, and then pick label. You can select the label here. You can select the labels, including this dimension. When you click auto identify, axis will be generated. So whatever software generated axis will be shown in green color like this axis. So always actually first you need to identify axis only. Don't don't identify any footing or anything. First always identify the axis. Then come to pad foundation. Already we have identified the from the schedule. Now we need to identify the sideline. So pick sideline command. We can select the any one sideline of the footing based on the layer. So when you select it, it will automatically take to the picked layer location from the AutoCAD. Then you can enable this original CAD layer is AutoCAD drawing. Picked layer is it is moving the pad footing alone to the picked layer separate location. Then again you can pick label command. The pick label command actually they have made both the uh, footing label and the column label in same layer. That is why what I have done based on the color I identified. Pick label I selected the footing red color footing label. Then what I did when I click auto identify, so wherever we have the element, this element will be placed here. In case if any element has not come for any reason, then maybe you can select it using draw point command, you can place it. So to view the entities, you need to select here. This is for viewing the entity and this is for selecting the entities, batch command, or we can directly select. So when you are in the edit mode, you can directly select. So automatically all the rebars of the footing will be input into the model. So when you calculate it, you will get the rebars. So again, the complete calculation setting already you have seen the project settings, the calculation rule. It is available. CAD foundation, foundation settings, columns, everything it is available. Okay. So now I will go to the column rebars. So column rebars, how to identify automatically. For the column rebars, we have the drawing here. Column rebar table. So here we come. So depending on the system performance, maybe we can automatically identify the entire table. Otherwise, maybe we can identify from level to level. So now I'm working in the foundation floor, maybe and putting to plinth level. These are the columns I need. So what we have to do? So I should be in the column component, the left hand side. I'm going to the identify command. Then here you should use this command, identify column detail command. So when I click identify column detail command, it is asking pick sideline first. So I'll select pick sideline command. So based on the layer, because last time we changed it to color, so that is why I'm setting it to layer. So based on the layer, I'm saying this is my, see this drawing should be scale, otherwise it won't give you correctly. We need to scale the drawing. We need to scale the drawing, then we need to identify. The drawing should be to the scale. So pick sideline. This is my column sideline. So when I right click, it will go off. And then pick label. So this is my column label. Maybe all the labels I can select, including the table. Right click. Then pick rebar line. So this is a rebar line. And this is also a rebar line. That's all. All are selected. So here auto identify we cannot do. Better do the drag identify. The drag identify means the bottom entire row I'm going to identify. When I select the drag identify, it is asking left click and drag the mouse to select. So all these columns I'm going to select from here to here. So when I'm selecting all these, when I right click, another window will pop up. Yeah, this is the window. So here I need to set the heading. Actually, this is the name of the column. So this is the links. These are all the main bars, all main bars. Okay, this one all okay. But anyway, see though the link spacing they if they give different link spacing in that table. But anyway, software can take only one spacing. After that, you may need to modify in the column. You know how to modify the links. So when I click OK, then software will identify all these rebars. So here now we have the rebars. So whatever columns, it does automatically identify the rebars. But anyway, we have to check whether all the rebars have come as expected. Here, so C1 20 numbers of T20. So maybe I will open the drawing. So this is the C1. So C1, T8 at 100, T8 at 100, T8 at 150. Is it on main link? Is it to link? Is it on others? Anyway, different companies are following different format. So as per our requirement, anyway, you know how to modify the links. So here this type of link has come, but actually the triangular link is required. So maybe I can delete this link and then T8 at 100 raw link, T8 at 100. Let me do later, I can change it to 100 using line command. So other links and all, if it is okay, then maybe different links of a different uh, spacings if we need, we can set it here also. And then here also we can set different spacing. I can go here and then maybe here if you want to modify, I can enable this. I can modify this. So edit links. So all these spacings, maybe if you want to set it as 150, you can set it as 150. So maybe see whatever changes we have done is only for C1. Again, instead of changing into C7, what I can do, I can go here. I can delete it. Maybe I can copy this one. I can rename it as C7, or it is automatically done. C7, and then similarly C2. So for the C2 also it is done. So maybe here also same. Maybe link, if I want to delete, I can delete. I can modify the link. So again, we need to check all the location, all in all the columns whether the rebar has come as expected. Then after ensuring it, so how to make it in the model? I should go to the column. Sorry, not column. This is definition mode. I should go to the footing layout. So columns are done. I need to place the columns into its appropriate location. So how to place into appropriate location? Here we have the identify column command, pick side line. So this is my column side line, pick label command. So you know already that based on the color we need to identify. So this is my column label. Then when I say auto identify, so all the columns wherever it is matching with this label and this element, it will come up with the rebars. So I can calculate. If you want to see the rebars in 3D, I'll be seeing the rebars here. Putting rebars. So can you make the rebars like this for the columns? I will repeat it again. So whoever understood, maybe they can try. I will repeat it again. So let me delete the columns. To delete the column, function F3 or function F3 or batch selection. Select all the column. Okay. Delete it. And then elements. Elements also I'm going to delete. Shift key. Delete it. It's taking time to delete C5, 3, 2, 1. Okay. And then the footing layout. I think already we have picked a layer will be there in the column information. So this also label, including label. If you want to send it back to the drawing, I can destruct identity. I can select everything, right click, it will send back to the drawing. So in the original CAD layer, it has come. Then, okay, now almost whatever we have done, we have undone. So maybe you can do it again. So what is the procedure? First you should go to the column component, then open the column rebars. This is the column rebar table. So your okay, column rebar, maybe this also maybe you need to send it back. Destruct identity. Okay. So when I double click, this is the column rebar table. So we need to select this command, identify column detail command. When I select this command, it will ask you to pick side line. So I'm going to select the side line. This is my column, side line. Select it. So right click to confirm. Right click. Then pick label. So this is my label. I can select this and this, including table. And again, right click. Then rebar line. So this is my rebar line. Right click. So after that, go here, select a drag identify. It will ask you to select the columns. Maybe I can select from here, only up to here. It will pop up a window. There you need to set, this is the name of the column and this is the main bar. That's all. When you click OK, columns will be generated with the rebars. Then you can cross check whether all the columns have come correctly or not, like that. Here, if any modification if it is required, now you know how to modify here, modify it. So you need to check all the columns whether it has come correctly or not. Then what you have to do, you should go back to the footing layout where I can see my column information. We need to place the columns right into the model. So I will go back to the footing layout. I'm going to identify because my footing is here only. About this one, I want the column. So what I will do, I will select identify column command, pick side line. So this is my column, pick label based on the color. Then when I say auto identify, then all these elements will be placed into its appropriate location. So the direction is changing. Quantity, calculate. Then see in rebar 3D, we have the rebars. So this is how you have to work with the columns. Okay, I will show the beams now. So how to make the beam rebars. So now the column and the foundation we have done. So the beam rebars, the plinth beam rebars. So I should go to the ground floor, so that when I make the beams will be at the bottom. So maybe the column I can copy from the foundation floor. So how to copy from the foundation floor? The entities, I should go to the draw, copy entity from other floor. So column alone to my ground floor. Maybe first floor also, if you want to copy, I can copy. Then I can open the plinth beam layout. So for that, first I should go to the, if I want to read the beams, then first I should go to the beam table. I'll go to the beam first, beam component, then plinth beam rebar table. So this is the rebar information. So how to read this table? So when I am in the beam, and then in the identify menu, when I am in the identify, when I am in the beam component, and when I am in the identify menu, this identify schedule will be there. When I click it, it will say, it will ask you to select the table. So we need to set the headings here correctly. So for example, this is the beam name, and this is the beam width, and this is the beam height, and then this is bottom rebar. See, actually, they are not bothered about whether aggregate can be placed, dropped inside the beam or not. Simply, they are given plus symbol. So, if you are giving plus symbol, it will not make it in another layer. It will be it will make in the same layer. So, this is the bottom rebar left. So, bottom bar, left support bar, and then bottom bar, middle, and then again bottom bar, right support bar. Now top bar, left support bar, top bar, middle bar, top bar, right support bar, and this is links. Okay, left intensified link. left densified. This is normal link in the middle. This is right densified. Okay. So this information we can delete the row. And then this I can delete column. See, if you think the same rebar will be used in other floors also, maybe you can enable floor 1, 2, all the floors. But here we are making only in the ground floor. Okay. And also here they should not give like this actually PB1, 6, 18, like that they should not give. Actually they should, because it will take the name itself as a PB1, 6, the span name. So for that, right click, insert a row, then right click, copy command, paste. So this should be PB1 and this should be PB6. So similarly, you need to modify here also. So each and every span should be shown separately. Okay, this I can delete column. Okay, let us check. See, generate in beam schedule. Generate in beam schedule means, see, I'm not generating directly the element. I'm generating in a beam schedule. What they have done, locally they are making one schedule, so that later maybe if there is any changes, we can go to the schedule, we can modify there, and then from there we can take it into the element, generating element. So they are making locally some schedule. So first we can make the local schedule. So before, when we click this, if there is any errors are there, it will pop up. So let me try here, generate in beam schedule. When I click, some invalid data. So what happened actually, this 2L center to center and all, now they are not accepting. Okay, let me find and replace, including, okay, this is not there, I think. 2, 2L, one, replace all, and then this hyphen also, 3T16, replace all. Okay, center to center is there, C/V, replace all. Okay, now let me generate in beam schedule. Let me see if there be any other issues. Okay, no issues. So this is the local location where it is generating. Identification finished. Enter beam schedule to view the identified elements. Yes. So this, so for the beams you have to follow this procedure. So when I click, so here when I click, see in back side one dialog is there. Here one dialog is there. So this is the final one. Here I need to generate an element. So when I click generate element, all the beams will be generated. So you can see here PB1, PB6, PB2, like that it is generated with the rebars. Okay, now I should make the beam 3D. So for that I will go to the clean the beam layout here, clean the beam layout. Okay, first I need to relocate to that column. Based on this column or grid also I can relocate. So I'm moving this clean the beam layout to this location. So columns are oriented. Okay. Relocate. I need to check actually why the columns are oriented. Okay. This let me check later. I don't know why the column. I'll check and I will let you know. Okay, if you want to identify the beams, then I need to go here, identify, sorry, it's a column. I should go to the beam. So identify beam command. Pick side line. So this is the beams. Pick label. This is the beam label. And then we need to select auto identify. But anyway, see, this will not come properly because the columns are oriented. Okay, see this color, this orange color, if it shows like this, the supports are not properly taken. So for that, see, I told you, the manually at local location, it's making the beam schedule. So this is that location. When you go to the draw menu, so this is the beam schedule location. That beam schedule will be there. So whatever generated from the table. So here we have the sync beam info. So here sync beam schedule into entity. Entity means 3D model. So 3D model is now ready. So whatever beam sync beam info, sync rebars will be beam rebars will be synced into the entity. When I click OK, it will be synced now. So now it is showing in green color. So we can calculate and we can check. But anyway, uh, because of the rotation of the column, so it may not have taken the supports properly. So I need to recheck that. Okay, but anyway, this procedure you need to understand how to make the beam rebars. And also, as I told you, by default, it might have made for the spans only. If it is a continuous beam, then what you have to do, you need to select the beams. Wherever it is a continuous beam, you need to select it like this. You have to select like this. Then right click. As I told you yesterday, you need to merge element and entity. When you click this, then it will be converted into a continuous beam. So after making like this, you need to always, for the continuous beams, you need to do that exercise. See here, from PB 25 to 28, it is made as continuous beam. Actually, in the side label rebars, how it will take from left to right for the horizontal beam, from bottom to top, the vertical beams. So like that, the rebars will be taken. Is that clear? But anyway, I will repeat again. But you need to understand this procedure mainly for the beams. Reading the beams is a additional process you need to do. I will tell you again how to read the beams. So whoever understood, maybe I can make. Again, I will do the beams. So how to delete the beams? Simply I can drag select and delete the beam, or batch select, I can delete the beam. Then all the elements need to be deleted. You have to delete. Yeah. So if you want to send it back, we can send it back also here. This one, identify list of entity. You can send it back to the AutoCAD drawing. And then table. In the beam, rebar table. So to read the beams, okay, better I will do it here. So first we need to read the beam table. So select the beam schedule, drag window the beam table, and then set the headings. This is the beam name. This is a width. This is height. And this is bottom bar, left support, bottom bar midspan, bottom bar right support, top bar left support, top bar midspan, top bar right support. So this is the link. Left intensified, midspan, right intensified. So we can delete this two column. Can delete these rows. So if you want to modify this PB1 into PB6, then we need to right click, insert a row. You can copy this row and you can paste it here. So modify this as PB1 and this as PB6. That's all. So if there is any errors, it will pop up when I generate in beam schedule. So RS I can replace with the here center to center. I can replace all with empty, and then to hyphen replace all, and then hyphen replace all. So generate in beam schedule. So beam schedule will be generated. When I click yes, it will pop up a dialog. You have to make the, you have to generate the element only here. So here when I generate element, the elements will be generated, beam elements. Here I can close the beam elements generated. So now we need to place these elements into model. First, for that, we should make the model first. So where the plinth beam layout, here the plinth beam layout. So here I can select the side line. Pick the side line command. So this is the side line of the beam. It's not selected. Sorry, it's not selected. Undo. Pick side line of the beam. So where the lines are very clear. Okay, here. And then pick label. So when I say auto identify, the beams will be generated. The beams will be in different color. This pink color. That means the rebars have not come. So to get the rebars, the beam also there, model also there, but to get the rebars, I need to enter into beam schedule. So here only it made actually the beam schedule. From here, I need to click generate element. So when I click sorry, not generate element. Generate element means the element will be generated. So already the element is generated. Only thing is whatever rebars present in this schedule should be input into the model. So for that there is a sync beam info. So here sync beam schedule info into the entity. So all this rebar information will be put it into the beam entity. So when I click OK, so it will become green color and also rebars will be synced. So this is the procedure. You have to follow this procedure. So when I calculate, calculation will be done. You see in rebar 3D, you see in rebar 3D. But so for the continuous beams, so all the beams will be made as a separate spans. So the rebars will be truncated at every support. So in order to continue the rebars, you need to make it as a continuous beam. So how to make the continuous beam? We need to select whatever beams are continuing, then right click. There is a merge element and entity command. When you select this, then it will become as a continuous beam. So here you can see all these beams have become continuous beam. Then you need to calculate. So this is the procedure for the beams. For anybody, any doubt? Maybe for the slabs we can see tomorrow. Is that fine?
Okay, sir.
Okay.
Hmm.
So any doubt for anybody? But in beams only, you need to follow the procedure. Maybe the recorded video, if you go through, then you need to follow that procedure. Only then you will get the beams automatically. But this type of beams, I think, mm, so this type of beams and all is a different method actually. For each and every rebus, anyway, you need to measure here. So you'll be having the longitudinal section of rebus like this. So you need to measure each and every rebar. That I will explain you tomorrow. But reading from the table is the easiest way. But anyway, you need to follow this procedure. Only then you will get automatically all the rebars present in the table into your 3D model. But anyway, you have to check also whether using the side label command, whether all the span, whether you have got the rebars as expected. That is also still there. Checking also is there. Okay. Thank you all. We'll meet tomorrow. Is that fine?
Okay, sir. Thank you.
Yeah. Thank you. Bye.